In this video, we'll be learning how to draw standard angles using the coordinate plane, and then we'll also learn how to find what are called coterminal angles. So let's start by defining what an angle will look like when it's written in standard position. And an angle written in standard position is an angle that has a vertex at the origin. So that's what you can see here. You can see that here our angle that we're forming, the vertex is right at the origin, or the point 0, 0. Its initial side, or the beginning side of that angle, always lies on the positive x-axis. So you can see that here. So we always start our angle at this particular location, and then we draw our angle to have a terminal side that is going counterclockwise. So notice how it went counterclockwise there. And whenever we reach that angle measure, it stops, and that's our terminal side pointing outward. So the big thing is that this angle starts at 0, 0, goes along the x-axis with its initial side, and then from there goes counterclockwise until it reaches its angle measure to a terminal angle. So if we were to draw an angle in standard position, and say we wanted to draw the angle of, let's do 120 degrees. So what we would do is we would go to the coordinate plane, we would start at 0, 0, and we would draw our initial side. Now, what we know about angles is we know that when we get to this point right here, we are 90 degrees. And we need to go 30 degrees past 90 degrees. So we're going to be somewhere between this line and this line, because this is 180 degrees and this is 90 degrees. So we're going to draw it about right there. That's going to be our terminal side of our angle. If we want to be really specific, we can put a little 30 degrees in there to denote that I went to 90 and then added an additional 30. But this right here, notice I went counterclockwise. I have my initial side on the x-axis, there's my vertex, and then I drew until I reached 120 degrees, which is about 30 degrees past 90. So let's practice drawing a few more of these. This first one is 240 degrees. So I know I'm going to start at the origin with my initial side here on the x-axis. I then also know that as I draw this angle, this is going to be 90 degrees, this is going to be 180 degrees, and then 180 plus 90 gives me 270 degrees over here. So I know that my 240 is going to be past 180, but not quite to 270. And it's really 180 plus an additional 60 degrees that I need to go. So it'll be about 30 degrees away from 270 degrees. So I'm going to start drawing this angle by going around through 90, through 180, and then I'm going to go about 60 degrees past 180 to about right here. So my terminal side of that angle is going to be in this direction. Now you don't need this little loop-de-loop here. If you want to draw that, that's fine. But what I need to see is that you have your initial side along the x-axis, your vertex at 0, 0, and then here about 60 degrees past 180, I have my terminal side of my angle. Now if we look at the second example here, this one might look a little strange because it wants us to draw a 500 degree angle, which seems like it might not be possible, but it actually is. So we're going to start here again. We're going to go vertex and initial side. And what you need to know about drawing these larger angles is you just need to note that you have 360 degrees in a circle. So here we're going to go 90, 180, 270, 360. So we've gone all the way around the circle. So we're going to actually go all the way around this circle once. And then we're going to go again. So 360 plus 90 is 450. And then 450 plus 90 would give me 540. So I know that I'm somewhere between these two when it comes to a 500 degree angle. Now I know I'm going to be about 50 degrees past 450 and about 40 degrees away from 180. So I'm going to draw my terminal side coming out of here. And I like to note that it's about 40 degrees away from that x-axis line. I typically note how far away I am from the x-axis. So here if we continue, now the little loop-de-loop denotes that we went all the way around once to 360, and then we continued on until we reached 500, which was about 50 degrees past 90 or 40 degrees away from 180. Then finally we have a negative 50 degree angle, which again doesn't seem like it's possible, but it really is. If we're doing a negative angle, essentially what's going to happen is we're going to go in the opposite direction. So instead of going counterclockwise, we are going to go clockwise. And that denotes that we have a negative angle. So we start here at the origin, and we go out along our x-axis, and then we're going to go 50 degrees backwards. So we're going to go clockwise instead this time, and this denotes that we have a negative angle. So what's interesting here is when we're drawing angles in standard position, we can have any normal angle between 0 and 360, we can have angles that are larger than 360, and we can have angles that are a negative degree because we can use direction to denote the degree of the angle and if it's positive or negative. So coterminal angles are defined as two angles that are written in standard form and that have terminal sides that coincide. So the easiest way to see this is to just do an example. So let's say that we have this angle here. So we have our vertex, we have our initial side, and let's say that this is a simple, we'll do a simple 40 degree angle. So we can see here that that's our angle written in standard form. Now, coterminal angles are angles that essentially end in the same location. So what we saw previously is that standard angles can go around and around and around the coordinate plane for every 360 degrees. So a coterminal angle that coincides with angle 40 degrees is going to be an angle that goes all the way around the circle and hits again at this same ending point. And the easiest way to find these is to simply note that we have 360 degrees in a circle. So in order to go all the way around and end in the same spot, we would have to add 360 to that angle in some capacity, or we would have to subtract 360 degrees from that angle in order to end in the same spot. So what we can do here is we can take our 40 degree angle that we started with and we can add 360 to it, and here in this case we would get 400, and we can note that a 400 degree angle would have the same terminal side as 40 because it would go all the way around for 360 and then add 40 on and end in the same location. We can continue to add on multiples of 360, so this case it would become 760, and that would be another coterminal angle. They're all going to end in the same spot because they simply go around the coordinate plane 360 degrees and end in the same location as that 40 degree angle. Now, in addition to having the ability to add 360, we can also subtract 360 and create an angle that's going to go in reverse. So say I didn't want a positive angle, say for some reason I wanted a negative angle, what I could do instead is I could take the 40 degrees, go clockwise, which is backwards, or a negative 360 degrees. That would bring me to negative 320 degrees. And again, I'm going to end in this same location here because I'm going exactly 360 degrees around the circle. So all we need to do to find coterminal angles is add 360 degrees multiple times or subtract 360 degrees multiple times, depending on whether we want a positive or negative angle to result. So in this slide, we're going to practice finding coterminal angles. And for these, I want us to find one positive coterminal angle, and then I want us to find one negative coterminal angle. So we can find those in any way that works for us. So let's start by looking at negative 45 degrees. So I'm going to start by just drawing this angle because I know then I have an idea of where it's going to end up. So here is my negative 45 degree angle, and I'm denoting that it goes in clockwise direction. So what I'm going to do here is I'm going to find a coterminal angle, and I know that to do that I need to add or subtract multiples of 360. So I'm going to take negative 45 degrees to start. I'm just going to start by adding 360 and seeing what happens. So that means I'm going to come around and I'm going to end up at this location. And if I add 360 with that negative 45, I end up with 315 degrees. So one option for a coterminal angle that is positive would be 315 degrees. Now, if I wanted to find a negative coterminal angle, so I wanted to continue going in this negative direction, I can do the same thing but just use subtraction on that 360. So here we can take negative 45, subtract 360 from it, and we find a coterminal angle of negative 405 degrees. Now if we take this angle over here, we have 395 degrees. So we know that we're going to start off, because it's 395, going all the way around the circle, because that gets us to 360. The easiest way to find how many degrees we have left is to subtract 360 out of it, and we find that we have a 35 degree angle. So here for our angle, we're going to go, there's our initial side, and we're going to go about 35 degrees up here. So I'm going to label that 35 degrees. And I note that I went all the way around the circle with my little loop-de-loop, and then from there I went all the way up to 35 degrees. Now what's cool about drawing this 395 degree angle is just in doing that we subtracted 360 and found that one coterminal angle is 35 degrees. So we've already found one of our angles just in drawing that angle in standard position. Then from here we have our positive angle, so we need to find a negative angle. The easiest way to do that is to take 360 and subtract it again from that 35 degrees. So if I take 35 degrees and subtract 360 from it, I'm going to find that I have an angle of negative 325 degrees. And that would be another angle that is coterminal with that. So if I can kind of imagine, here's 35. And if I went in the negative angle direction, 360 degrees, I would end up at that negative 325 degrees.